So problem number 16. We had a function, so it was the whole graphing thing again. We worked one of those out in its entirety yesterday. So we have this one. They take quite a bit of time. So the domain, if I'm looking at this, that's asking what x can be. And easier way to think about it, what can x not equal?
0.
So our domain is negative infinity, 0, union, 0 to infinity. How do we find an x-intercept when the y is 0? So maybe the easiest option here is if you take everything times x squared. Do you want Thank you. Alright, so then we need things that multiply to 1 and add to 1. And does it work? No. So if you do quadratic formula, opposite of b plus or minus the square root of b squared minus 4ac all over 2a, what kind of number are you getting? Imaginary, because we're having a negative under the radical. So at that point I can realize I could just stop and say there is no x-intercept. Y-intercept, that's when x is 0. What happens if you plug in 0 for all of your x's? It's undefined, we can't do that, so there is no y-intercept either. So we have a graph, no x or y intercepts. So it never hits an axis. Alright, and then I asked you for I told you guys you could skip the symmetry part. Didn't I tell you that? I meant to tell you that. Was it on there?
Yes, but I did not do the
Okay.
symmetry.
I told you. I meant to not include it, but forgot to take it off. Alright, so vertical asymptotes. X equals what makes the bottom 0, which is just 0. So that's why we didn't have a y-intercept, because it's a vertical asymptote. Horizontal asymptotes, how do we find them? Okay, a number over infinity goes to 0, so we just get 1. So our horizontal is y equals 1.
So the vertical asymptote is whatever makes the bottom 0.
Mm-hmm. Okay, if I want increasing and decreasing, what do we have to find? First derivative. So derivative of 1 is 0. There are different ways to write this. You could say 1 plus x to the negative 1 plus x to the negative 2. You could also turn it into a fraction, like with common denominator if you wanted, so whatever you guys like. So we should get negative x to the negative 2 minus 2x to the negative 3. That's the same thing as negative 1 over x squared minus 2 over x cubed. Alright, we are looking for critical points. That's anywhere this is 0 or undefined. So if we set it equal to 0, we have negative 1 over x squared equals 2 over x cubed. If you multiply by x cubed on each side, those cancel. Cancel 2 of those, so we get a negative x equals 2, so x is negative 2. So our critical points are negative 2 and what's the other one? 0, because that's where it's undefined. Okay, so for increasing, decreasing, we do our sign line, test points. Where do we plug these in? First derivative to check positive or negative. When we need points on the graph for the maximum, we put them in the original. Alright, so if I put these in, our derivative, I put in a negative 3, that would give me a negative 1/9, minus 2 over negative 27, so plus 2 over 27, and that would turn out to be negative. If I put in negative 1, we get negative 1 over 1 minus 2 over negative 1, so plus 2 over 1, so that is positive. If we put in a 1, we get negative 1 minus 2, which is negative. So our graph is increasing between negative 2 and 0, decreasing elsewhere. All right, then I asked you for max and min. So if you go from decreasing to increasing, that is a min. We need the order pair, so if you put it into the original, so negative 2 into the original, it would be 1 minus 1 half plus 1 fourth. So 1 half is like 2 over 2, or sorry, 2 over 4 plus 1 over 4 would be 3 over 4. Increasing to decreasing would be a max at 0, but can you plug 0 in? No, so we get no max, because it's not an actual point on our graph. All right, what do we need to find concavity? All right, so the negative 2 comes down, so it would be a positive 2x to the negative 3 plus 6x to the negative 4, 2 over x cubed, 6 over x to the 4th. Set that equal to 0. Multiply x to the 4th over. So that will cancel 3 of them. So 2x equals negative 6, so x is negative 3. So inflection points, negative 3, when the second derivative is 0, is the second derivative ever undefined? Yes, at 0. So negative 3 and 0 have to be checked. Check our concavity, so sine line, put them into the second derivative. So if you put in a negative 4, you get 2 over negative 64 plus 6 over 256. So it would turn out negative. If you put in a negative 1, we get negative 2 plus 6, which is positive. Put in a 1, 2 plus 6 is positive. So this is concave down from negative infinity to negative 3. Can I just say concave up from negative 3 to infinity? Why do we have to break those up? Yes, because of the asymptote. All right, let's go ahead and get the actual order pair for that inflection point. So if we put negative 3 into the original graph, that would be 1 minus 1/3 plus 1/9. So 2 over 3 plus 1 over 9. So 2 over 3 would be like 6 over 9 plus 1 over 9 is 7 over 9. So negative 3, 7/9 is an inflection point. How do we mark those on the graph? X's. It's just under there. We had, let's see, our min at negative 2, 3/4, so just a little bit less than that. We had no other maxes or mins. So our graph has to be decreasing to begin with and curving downward. Right, so curving downward, like this, we know as we're getting close to an asymptote. Then it switched to concave up, but we're still decreasing. Okay, we're staying concave up, but our graph is increasing. And then we check after that, our graph is now decreasing and concave up. So it's falling, but curved upward. Look like this.
So why can't we cross the horizontal?
You can always cross horizontal asymptote. Those are what your graph is approaching as it goes to infinity. It doesn't tell us what the graph does in the middle. So you can never cross a vertical asymptote because that's where it's undefined, but you can cross a horizontal. other questions? All right, so those are definitely the longer problems. Make sure you are prepared for one of those. Next up, problem 17. All right, a farmer has 600 meters of fencing with which to build a rectangular corral. We have a rectangle. Some of the fencing will be used to construct two inner divider fences, both parallel to the same sides. So we have two fences on the same, or on the center. They're parallel, so you could draw them like this. You could draw them going the other way. It doesn't matter. We know that we are looking for the maximum area. So area is just length times width. So we need some variables here. What do you want to call this side? All right, so if that's x, then this is x, and this is x, and this is x, right? We don't know these, so if we called them y, our area, length times width, will be x times y. If we want to maximize or minimize, what am I asking you to do? Find the derivative. But do we want to do the derivative when we have multiple variables? No, not really. It's not going to turn out pretty because we have to do implicit differentiation, and that's way too much. So before we can do the derivative, we need to get everything in terms of one variable. What other information were we given in the problem? Yes, the amount of fence. That's like if we add all these sides together. So there are 4 x's and 2 y's, and I know when I add them all up, it gives me 600. So I can solve for either variable. I'll just solve for y. So 2y equals 600 minus 4x. So y is 300 minus 2x. So now my length times width becomes x times 300 minus 2x. What should I do before I do my derivative? Yeah, simplify, distribute that out. So now if I want to maximize, we do our derivative. So derivative of 300x is 300 minus 4x. Anytime we're doing a maximum or minimum, we do the derivative and set it equal to 0. Divide by 4, and we get 75. So we wanted to find the maximum area. So if this side is 75, this one becomes what? So the maximum area, 75 times 150 gives us, and we were in meters, square meters. Is that okay? Problem 18. Suppose you are making a rectangular box with a square base from 2 different materials. Alright, this should seem familiar because we've done these a few times. Everybody's favorite. So I have a box. If the base is square, what does that tell me? So the base, the bottom, is a square. Those sides are the same. But it's not a cube, so the height is something different. Material for the top and the sides costs $1 per square foot. The material for the base costs $2 per square foot. Find the dimensions of the box with the greatest possible volume if you are allowed to spend $144 for the material to make it. So I want to maximize volume. Volume is length times width times height. So that would be x times x, or x squared y. Just like the last one, we don't want to do the derivative until we only have one variable. So that's where the other information comes in. The cost. My total cost is $144. You get that by adding in the cost of all the sides. So the bottom, what's the area of the bottom? And how much do we pay for the bottom? $2. So we have to take that times 2. All right, what's the area of the side? And how much do we pay for the side? $1, so 1xy. Okay, what about this one? xy, so it would be 1xy. This one, xy, and this one. So there's 4 sides, they cost $1 each. Could I just write 4xy? And then the top. What's the area of the top? X squared. How much does the top cost? $1. So it's 3x squared plus 4xy. For solving, probably easier to solve for y, so we can subtract over the 3x squared. And then we would have to divide by the 4x. So I put that into my volume. We could cancel one of these x's. So if we distribute, that's 144x minus 3x cubed over 4. Or if you don't want to have to do quotient rule, just think that's like each one over 4. So 144 over 4 would be 36x minus 3/4 x cubed. So I have now written an equation for my volume that has only one variable in it. Since we need to maximize our volume, now what do? Derivative equal to 0. So the derivative is 36 minus 9/4 x squared equals 0. So multiply by 4 over 9. 36 divided by 9 is 4. 4 times 4 is 16. Normally, if you do a square root, you have to do plus or minus, but can x be negative? No. So our x is 4. So we were asked for the dimensions. So the base is 4 feet by 4 feet. The height, we just plug our 4 back in for the y. So we get 1648, so 96 over 16, so 6 feet. So if I ask for maximize or minimize, you have to get an equation with only one variable and do your derivative equal to 0. Alright. Last page. 22. So we have the sum. J equals 1 to 8. 5 minus 2j. Alright, let's review our summation rules. So you add up from 1 to n of a constant. What do? No, a constant. Not over, but times. Because if I'm adding up 5, for instance, 10 times, it's 5 plus 5 plus 5 plus 5, total of 10 times. So if you add up a constant, it's just your number times the constant. If you add up something to the first, that was what? If I add up something to the second, over, if you add up I cubed, just like your I formula squared, n squared times, hold on, should be a plus. N times n plus 1. Okay. All right, so now let's use that formula here. If I add 5 up a total of 8 times, that becomes 5 times 8 minus 2. All right, if I'm going to add this up 8 times, it's a j to the first. So it's n, what's my n? Times n plus 1 over 2. So we get 40 minus, those 2's would cancel, 72, so negative 32. We just had to do our summation rules there. Alternative, if you want to take a little time, could you plug in every number from 1 to 8 to get those answers and add them together? Yeah. 23. We need the sum from 1 to n f of x sub I times change in x to approximate the area when our function is x squared on the interval 0 to 2. All right, so first on these, we have to find our change in x. Change in x is ending minus beginning divided by the number of rectangles. So 2 over n. Then we have to find our x sub I. X sub I is our starting point, which was 0, plus the change in x times I, because you're adding up multiples of that. So that would just simplify to 2 over n I. So now we do our summation. So sum from I equals 1 to n. F of x sub I just says you are plugging your x sub I into your function. So that's 2 over n I squared times the change in x, which is 2 over n. Okay, 2 squared is 4, times 2 is 8, over n squared times n is n cubed, I squared. Right, but now we could do summation rules because it said to calculate this sum. So, if we are going to add this up, we have the I squared formula, which is n times n plus 1 times 2n plus 1 over 6. So that's from the formula that I jotted down on the previous slide. All right, now we have to try to clean this up as much as we can. So we're looking for things that reduce. 8 over 6 you could reduce to 4 over 3. We could cancel one of those ends right away. So then if we multiply out what's left, we have 4 times 2n squared, 3n plus 1 over 3n squared. And that would be 8n squared plus 12n plus 4 over 3n squared. So this is the first part. This is the calculation. We have a formula. So now if I tell you what n is, you can plug it into this formula and tell me the value of the area. Next, it said in the question, then find this area exactly by taking the limit as n approaches infinity. So at this point, I would probably split them up. There's different options. You could divide everything by the highest power of n as well, so it'll amount to the same thing. If I put each one over the 3n squared, 8n squared over 3n squared would just be 8 over 3. 12n over 3n squared would reduce to 4 over n, and 4 over 3n squared. And we know that if you have a number over infinity, it goes to 0, so this whole thing just turns into 8/3. So this is what we did back before we knew that an area was the same thing as an interval. Is that one okay? Left, right, and midpoint sum. Our function, x squared plus 2x. Our interval, 1 to 4. Number of rectangles is 6. What do we need first? Change in x. End minus beginning divided by n. So 3 over 6 is 1/2. So think about when we did these. We essentially were adding up the areas of 6 rectangles. The rectangles are length times width. What's the width of all these rectangles going to be? 0.5, 1/2. That's what we just found. So if you wanted, you could write the 1/2 or the 0.5 out in front. And then we just need the 6 things that we're adding up. Okay, so to get those, we need to know what to plug in. My interval starts at 1. My x is increasing by 0.5, so the next one would be at 1.5. So if you want the left, we start with the leftmost number. So the first one I plug in is 1. So you would have 1 squared plus 2 times 1. Then you're increasing by the 0.5. So 1.5 squared plus 2 times 1.5. Add 0.5 and then we're at 2. 2.5. 3. And the last one is 3.5. All right, so then you put all that in your calculator now on the final, where I'm not, I'm writing it for you to be able to do it without a calculator. I probably would not have you calculate it. I would just say set it up. But you should get 30.875 if you plug that all in. Then the right-hand sum. So if I'm dealing with this from the right, which number is on the right? The 1.5. So the first number I plug in is the 1.5. And then it's all the same. So we're starting with this one. So then we have the 2, the 2.5, the 3, the 3.5, and then the last one is the 4. And if you plug that all in, you should get 41.375. So we can tell the left-hand sum was our underestimate, the right is our overestimate here. Midpoint, we start with the middle. What is in the middle of those two numbers? So that's what we're plugging in each time. So 1.25 squared plus 2 times 1.25. Okay, 6 total. You're still increasing by 0.5 every time, so the next one will be 1.75. 2.25. 2.75. 3.25. And the last one, remember our interval ended at 4, so we can't go past that, but the last one is 3.75. And if you calculate that, you should get something in between your left and right hand sums, which was 35.9375. Is that okay? 25. We need to write our limit as an integral. So when we do that, our limits are the starting and stopping points of our integral, which were what? 0 to 3. Okay, so that integral takes the place of the limit of the sum. Our function, all you do is drop the x, the sub I on the x, so it's just x cubed minus 3x squared plus 1. And change in x gets replaced with what? And that's all I asked you to do there. You didn't have to calculate anything. 26, we need to integrate. Can you do the antiderivative if you have a product? No. Is there any way to multiply this out so we don't have a product anymore? If you want to FOIL the 1 plus x squared, you could. The other option is a u substitution, and both should get you there. This one, since squaring isn't too hard, we could probably do that. It would be a 1 plus x times 1 plus x. So if you FOIL those, that's 1 plus 2x plus x squared. So we have the integral from 0 to 1 of x cubed plus 2x to the 4th plus x to the 5th dx. So integral means antiderivative. The antiderivative of x cubed plus antiderivative of 2x to the 4th plus antiderivative of x to the 5th from 0 to 1. Put in a 1. Always do upper limit first. Minus, then put in your 0. Alright, common denominator. Let's see. 60. So 49 over 6. Is that okay? Problem 28. So we have the integral from -3 to 3 at the absolute value of 3x minus 6 dx. Okay, we have reminded ourselves, yesterday we talked a lot about how you can't do a derivative of an absolute value, we also can't do an antiderivative. So I need to rewrite this absolute value. What's my breaking point? Okay, and why is it 2? Alright, So you have to figure out when 3x minus 6 equals 0, so that's when x is 2. So that's our breaking point. If you put in a number smaller than 2, so maybe a 0, then this is negative, and the absolute value would make it positive. So it's the opposite, because you have to make it positive. If you put in something bigger than 2, it's already positive, so the absolute value does nothing, it stays the same. So we're going to integrate from -3 to 2. On that section, that's when we have to do the opposite. You're welcome to go ahead and distribute that negative and make it a -3x plus 6. And then we're going to integrate from 2 to 3, and that's when it stays the same. So the antiderivative, -3 halves x squared plus 6x, -3 to 2. Over here, same thing, just opposite signs. Okay, so then we plug in our stuff. You have to put in the 2, so 4 times -3 halves would be -6 plus 12, minus, if you put in a -3, and then over here you do the same. You evaluate the upper minus the lower. And then for the sake of time, I'm just going to tell you that answer is 39. You would work it out. All right. Problem number 30. So we are doing fundamental theorem of calculus to find the derivative of the integral. So we had these on our last test, and we talked about a derivative and an integral are opposites. So what happens if you integrate this and then do the derivative, your t will get replaced with this. It has to go from a constant up to a variable. So our t would become the sine x squared. Everything else stays the same. And then what do we have to multiply by? Derivative of sine, because of the chain rule. So it just becomes cosine x times sine squared x plus 1 cubed. So just remembering that derivative and integral are opposites of one another. If it went from a variable up to a number, how do you flip it? Negative. All right, 31. Did we need A or B on this one, guys? All right, yes. So we have the integral. I'm going to rewrite that as 5z plus 4 to the -8. So if we do the antiderivative, we know that an antiderivative would add 1 to the power. So that's a -7, so we would have to have a -1/7 out in front, right? Think about if you did the derivative now. The exponent comes down, multiplies, those cancel, inside stays the same, subtract 1, times the derivative of the inside. What's the derivative of the inside? So to cancel that, we need a 1/5. So we get -1/35 times 5z plus 4 to the -7. And then, because I didn't give you numbers to put in, what do we have to put on the end? Plus c. Is b okay? 36. All right, so we have x equals 4y squared. So that's like a sideways parabola. And x plus 12y plus 5 equals 0. So that's just a line. Negative slope and negative y-intercept. So we are looking at like a decreasing line there. So when I graph this, it's not a very good graph, but we're looking at this area right here. If we are going to keep these functions, would it be easier to write them in terms of x or y, do you think? We usually like x, but the first one is 4y squared, so if we solve for y, we'll have a square root plus or minus, so that may not be ideal. So let's just keep the y. So if your variables are going to be y's, that means there's a dy on the end, and our limits have to be y values. So when we set this up, we need to find when those curves meet. Right, so the first one was x equals 4y squared. If you had solved the second one for x, that would be x equals negative 12y minus 5. So that's 4y squared plus 12y plus 5. So slip and slide or box method, whatever you like. So that would factor into y plus 10, y plus 2, divide by 4, 10 over 4 is 5 1/2, so 2y plus 5, and 2y plus 1. So our intersection points are negative 5 halves, negative 1 half. So all that work was to find out what my limits should be. And we were keeping y in for our variables, so we had to solve for y here. So we'll go small to large. All right, so then when we set this up, which one's on the top or the right here? That was, yeah, the line. So the negative 5 minus 12y or negative 12y minus 5 minus the left was my 4y squared. All right. So then at that point you do your antiderivative. So we have negative 6y squared minus 5y minus 4/3 y cubed. Remember, you plug in the top, plug in the bottom, and at the very end you should get 16/3. But I'm almost out of time, so I'm not going to show all that work. Is that okay? And the last question, problem 37. Let's make sure we can at least get this set up. We want the volume of the solid obtained by revolving f of x equals x cubed plus x squared around the x-axis on the interval 1 to 3. So if you put in a 1, 1 cubed plus 1 squared is 2. If you put in a 3, you get 27 plus 9 is 36. So this is increasing pretty quickly. So we're getting a curve like this. So when we're rotating, I told you, think of it as like a reflection. We're going around the x-axis. So what variable do we keep? X. So it should look something like this. So if we are rotating around the x, we're going to keep the x, so our limits should be x values, and I actually told you we're going from 1 to 3. Since we're doing volume, we don't just integrate the curve. What do? Pi times the radius squared, and we said it would be dx. The radius, so if we're thinking about a cross section, the radius is just the distance from the x-axis to the curve, and the curve was x cubed plus x squared. So we could take out the pi. To square that, you would have to FOIL, so you should get x to the 6th plus 2x to the 5th plus x to the 4th dx. So antiderivative, you have the pi, of course. 1/7 x to the 7th plus 2 over 6, so 1/3 x to the 6th plus 1/5 x to the 5th from 1 to 3. And then you plug in, and that gives you a horrible number. But lots of fractions that don't reduce here.